Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, today we will discuss about how to implement the set operation on the doubly linked list. So before starting with this, let's see the doubly linked list. So this is the doubly linked list. What is a set operation? Means if you wanted to update some value in a specified index, then we use the set operation. For example, here we have number 3 in the second index. Now instead of this 3, you wanted to change this to 15 for some reason. Okay, or you wanted to change the value based on the business requirement. So now we use this set operation. So for doing that set operation, what we will do usually, we will start from head. Okay, we will start checking the index from head and we will traverse through the entire doubly linked list, and we have to pass the index. So we have passed, let's say, index 2. So it will search for the index 2 starting from head to wherever it will reach the, or it will met that condition 2 is matching. Till then it will traverse. So 0, 1, 2, 3, 4. So till this point it will traverse, and once the index is matching, the 3 will be replaced with 15. So this is how the set operation works. Now first in the get operation also we have seen the similar one for traversing through from head to tail. So for that we have taken one temporary variable called current, because we wanted to have this head value always like self dot head should not be modified for some reason, right? So that time we will use this um, one temporary variable called current, and we will assign head to that, and then from that current we will do current dot next compare the value, current dot next compare the index value, current dot next compare the index value. This way we will iterate through each and every node until we get the correct match with the index number that we are searching and the index number that we are currently in. Once that is there, it will replace the value. Okay, this is what set operation does. Now let's write the code to understand this better. Let's take this Python compiler, and we have the yesterday's code where we have implemented the get node method, right? Okay, now here we will start writing the set method. Set valors, anything, okay, anything, any name you can use. Now for this, what details we have to send, self anyway is needed because it's a class method, and it requires the index value, in which index you wanted to update the data, right? So you need to pass these two values to this set method. And for get method we have passed only index because we wanted to get the value that is already present in the index. Set is, we will go to that, we will get the index of that and then get the data, I mean update the data with whatever we need. Okay, now while writing this function, as usual we have to code for all the edge cases. Now what are the edge cases that we might get it here is, here we are passing the index, right? So index should be greater than 0 and that index should be less than or equal to length of the this entire doubly linked list, right? So those two things we have to remember always. Now let's start writing the code. If the index equals less than 0, then we will return false. Okay, we will say that whatever we are trying is wrong, and then we will start with assigning the current temporary value with the self dot head. method. So what it does, whatever value that is there, the pointer of the self.head is assigned to the current variable now. And let's initialize count value here. Now let's write the while current. So here similar one we have done in the get method, right? Because why we are doing that is we have to traverse from head to tail. Whenever we have to do that kind of iterative operations, we will use the while here, because every time we have to check for a condition and then we have to traverse through the doubly linked list. So first one is whatever index that we are passing might be the 0th index, means the current index. So first let's add that condition here. So if count is same as index, which means that at the first place itself it is able to find that index, then what we have to do, we have to change the data, because this is what that this data is we got this data, right? With whatever data that is already there, we have to replace that with whatever currently we are having. I mean, we are fetching it, I mean, we are we getting it in the like an argument to this set value method. Okay, now once this is done, we will return true, means it is successful and we are returning true. And once we are out of it, we have to increment the count value so that it will go to the next index, because this is where we are checking, right? 0th index is done. Now we are incrementing it so that next time it will check the next index. And this count we have to again check, always compare with what? Current. With the current we have to assign as current to current next, which means that whenever count is increasing, we are moving the cursor next to the current, means each node we are traversing and we are searching for that particular index, and once that these two are equal, that's where we are assigning that new data to the current dot data, and then we are returning true. In case of, now this is what is the code. Let's say there is something like index is out of bounds, like this one, right? Index it should be there, but if it is out of bounds, then we will return false. For any other cases also we will return false. So this is high level. You can actually even be more specific about this length also, so that you can capture the exceptions very clearly. Here we are not adding any exceptions, so that will be really difficult for investigating any of the like triaging any of the issues, right? So that time it will be better if you have specific if else condition and having proper, like here instead of false you can just mention like index is less than 0, like that. You can always have the loggers for telling you what exactly is going wrong. Okay, now we have written the set value. Now let's print it. Print dll comma set val is what our function, right? Yeah, now we have to pass the index, right? So we will say we thought of doing something, right? In the second index 15 is what we thought, right? So second and 15. Now let's run this. Fine, let's print the list. That's when you will understand. It is returning true because we don't have any print statements there. But when you print the list again here, you can see in the 0, 1, 2 second position, earlier 3 was there in the second index, earlier 3 was there, now it is replaced with 15. Okay, this is how we will work with set method on the doubly linked list. Now coming back to the time complexity, so let's talk about the best case. In the best case, like this is the one, means at the first starting index itself we are giving the 0th index and change it to something else, right? Then there is no need of traversing from head to tail here. In the just with the one iteration itself we are coming out, the cursor is coming out, right? So here in this kind of codes we always will have order of 1. Okay, but we have the other cases as well. When you come out of this if condition, let's say it is not the 0th index, the first iteration, it is the whatever we are asking the change, right? The setting of the value is not at the index 0, then it may have to traverse through the entire doubly linked list. So let's say what is the worst case scenario. Worst case scenario is we are asking, user is asking to change the value at the index of the last value of the doubly linked list. Here only we have 5 values, so we can immediately say, let's say there are 1 million records in a doubly linked list. So 1 million times it has to traverse through the doubly linked list to reach that index and then set the value. So here multiple iterations are there due to the traversal. That's why the time complexity of this set val function is order of n. Okay. Now coming to the space complexity. If you take here, as we have seen, right, it is not, there is no need of any extra space or additional space, additional storage is needed here. We are just traversing through and then we are returning the value. We are changing the existing value. We are replacing the existing value with a new value. So nothing new has been created here. So space complexity of this particular function is order of 1. Okay. Time complexity is order of n and space complexity is order of 1. Okay. This is how set val method works in doubly linked list. I hope this is useful for you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.